Okay, hello algebra class. Today we're going to look at multiplying matrices. So in the last lesson we looked at adding them, we subtracted them, we scalar multiplied them, which means we basically just distributed a number across the entries in the matrix. But what happens if you multiply two actual containers, two actual groups of entries? In other words, multiplying two boxes, two matrices together. So the answer is sometimes you can do that and sometimes you can't do that process. So I wanted to look at four matrices. You can see A, C, R, and Z. We know their dimensions or their sizes, but the question is, can we form some matrix products? I wanted to look at these products. I kind of just made up some. And if we can find the product, what size would the product be? I don't even know what's inside these matrices. We're going to start out by just asking the question, can we do it? Can we multiply the boxes together or not? So let's have a look. Alright, so first, AC. In order to multiply matrices, you have to have the rows match the size of the columns, because this robot dance thing, it's definitely a dance move and you got to do it the right way, make Michael Jackson proud. That is the key to matrix multiplication. The inner dimensions have to match. In other words, the rows of the first column, the rows of the first matrix and the columns of the second matrix. Don't think of that real abstractly though. You're going to see if you make a mistake, but you can do this really quickly by just writing down the dimensions. So A is a 2 by 5. C is a 5 by 7. So do the inner dimensions match? In other words, do these match? Well, yeah, they clearly match. So that is possible. So I'm going to say AC is a matrix, and it is this size of matrix. So the outer dimensions are what are going to give you the size if you can actually form the product. CA. It's kind of hard to do this backwards. That's why I'd always recommend just writing it down. So C first, A second. On this one you can clearly see that those do not match. 7 is not 2. The rows of the first matrix, the columns of the first matrix don't match the rows of the second one. So CA is undefined. Doesn't exist. It's not possible to perform that multiplication. Alright, CR. Well, let's follow my dice again. So we're going to go 5 by 7. And R is a 2 by 7. Again, the inner dimensions don't match. So this guy is also undefined. RA. Let's see, it's a 2 by 7. A is a 2 by 5. Again, the inner dimensions don't match, so the product is undefined. At this point, I'd encourage you to pause the video and try those other three possible products out, see if they're defined and what size the product is. Here's RZ. They match, so that one is going to be a 2 by 5. And just to get us going for when we actually multiply next, 2 by 5, what's that mean? It means 2 rows, 5 columns. So if you're actually to perform this multiplication and you knew what was in R and what was in Z, you'd go 2 rows by 5 columns and you'd have 10 entries, 10 blanks to fill in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you'd go about filling that in. We'll see that in a second. So ZA though, can we do that one? It's a 7 by 5. A was a 2 by 5. The inner dimensions don't match, so not something we can do. Alright, ZC. Let's try that one. Okay, this time the inner dimensions do match, and the answer is going to be a 7 by 7. So we'd have to have a really big matrix with 49 entries, a nice square matrix, to perform that matrix multiplication. Okay, let's actually learn how to multiply matrices. So let me give you a couple matrices with some actual entries that we can see. So I'm just going to name some random matrices. Let's say we have C, and let's make it about this big. So putting some entries inside. There we go, C. And let's look at a W matrix. So let's say here's W. Okay, so can we add these matrices together? If I was to ask you to do C plus W or W plus C, you should tell me no, because good, uh-oh, I'm outside the box. Matrices have to be the same size to add or subtract or scale or multiply. I guess if you wanted to do 2W minus C, you still couldn't do that. They'd have to be the same size. But what if you want to multiply these guys together? Well, you might want to check using what we just learned. So this guy has 3 rows and 2 columns. W has 2 rows and 3 columns. So if they ask us to find the matrix product CW, can we do it? Since it's already right here, I'm going to not follow my advice and just look, do the inner dimensions match? The answer is yes. What size is the answer going to be? It's going to be a 3 by 3. So we're going to have to do 9 entries. How do you get those? First, don't be lazy. Definitely write down your matrices next to each other in the order that you're asked for. And now we're going to learn the Michael Jackson dance move, which, by the way, is key to a ton of different concepts in linear algebra. So much comes from this, not just how to multiply matrices. It's all about rows by columns. So here we go. I'm going to show my work a lot more on this first row. So I'm going to multiply 2 times 8. And then I'm going to slide. And I'd really recommend using your fingers during this process. So I'm going to do 2 times 8, slide, -4 times -1. And I'm going to add those together. Each one of the entries in a matrix product comes from a linear combination. That's what you call this, a linear combination. So that is going to be 16 plus 4. So the first blank is going to be 20. And I should probably set up all my blanks right now, right? We said it was going to be a 3 by 3. And I think I'm going to do these in different colors, actually, just to be clear. So we'll do the first 3 in red. So I hit that column with the first row. Now I need to hit the other columns with that first row, and then I'll be done with that row. So here we go. We've got 2 times 0. That's just 0. Slide. -4 times 13. I might need my calculator. -4 times 13. Well, that's 40 and 12. It's -52. All right, that's what goes there. Still need to hit this last column with that first row. So 2 times 2, it's going to be 4. You can write that out. How much work you show is up to you. Don't make mistakes, though. That's what it's all about when learning basic matrix computations. So that's 4. Then I've got -7 times -4. So that's going to be 4 plus 28, which is going to be 32. So there's the really long way to write out your matrix computations, or your linear combinations that you're doing. I prefer to do these with a little bit less writing. It's up to you, though. Make sure you don't make mistakes. Like I said, this is done. You can even cross out that row. It's hit all the columns. Now we're just going to repeat with the other 2 rows. So I'll do this one. So I'm going to go 8, slide, and 3 is 11. I can do that in my head, and I encourage you to try. So there we go, 0 and -39. Well, that's -39. We love zeros in matrix land. You're going to get more and more used to that idea, believe me. All right, so now here we have 2, and that's going to be a positive 21. Maybe I'll write that down. Okay, so it's going to be 23. About this level of work is what I think is really successful, but you do what you like. And now we need to hit all those columns with the last row. So I'm going to go -16, slide, and -6. That's going to be what? -22. And 0 and 6 times 13. Oh, might need to do a little scratch work. times 3 is 18. 6 times 1, that's 78. Okay, and the last one is going to be, it's going to be negative 4. Slide, and that's what, negative 42. So that's negative 46. Okay, so that is the matrix product CW. Kind of a lot of work. We're going to use our calculator to do these sometimes, but it's going to stop you from making mistakes in your mathematics if you're careful about doing these matrix multiplications. So it's valuable as a mental rigor process, boosting your mental abilities a little bit, in addition to learning how to do some vital mathematics. Let's try to do the product the other way. So that's CW. I'm going to leave it on the board, the answer anyway. Let's get all this other work out of the way. So that is CW. Let's do WC. So WC, I better write down my dimensions. WC. It's going to work because the inner dimensions match. And this one's just going to be a 2 by 2. Strange. All right, let's write it down and see if it works with our little dance. And you want to write your matrices spread out a little bit for mental convenience. All right, so we said we're going to get a 2 by 2, so I'm going to set up an answer matrix with 4 blanks in it. And here we go. Going to do the same dance. It's always rows by columns in matrix land and linear algebra in general. Rows by columns is pretty much the name of the game. So this time we're going to have 8 times 2. I'll write this first one out, this first linear combination out really in detail. Slide. That's going to be 0 times 1. Slide. 2 times negative 2. So that's going to be 16, nothing, and minus 4. That's 12. And I'm going to do the same thing, hit that second column with my first row. So I'm going to go 8 times negative 4. Slide, that's nothing, I'm just going to add 0. Slide, and now I've got 2 times 6. So that's going to be negative 32 plus 12. That's negative 20. Let's do that last one without showing our work quite as much. So here we go. We're going to go negative 2. Slide, 13. Slide, that's positive 14. That's 27 minus 2. It's 25. And now we've got 4, running out of room. Positive 4, slide, negative 39. Slide, negative 42. I need to whip out my calculator. Let's see, 30 and 40 is 70. That's 76. And 9 is going to be 85. Negative 85. So there we go. Before we sign off this time, I want you to think about this for a second. You've got CW. It's got 9 things in it. That's 9 entries for that 3 by 3. WC done the other way is totally different. It's a 2 by 2. So in matrix land, numbers don't commute. You're used to everything going like this, right? It's 21 either way you do that. Clearly matrices don't have the same property. I'll see you next time.